Files are very important, obviously. You have all worked with files on your own computer. If you open, for example, these lecture notes, they are stored in files. If you open a photo on your phone, this will be stored in files. So how can we actually deal with files in Python? There are several things I'd like to cover. First of all, a little bit about files themselves, distinction between text files and binary files. I will show you some examples, and we will also discuss CSV files, which are comma-separated files, and binary files to some extent here. So first of all, to get into the mood about what we are doing here, let's consider the following program, which should do the following. It maintains the students' scores in a course. This program has to allow adding students, editing their data, sorting and filtering the data, and exporting to the web. So what I want to say here is that so far we have used Python scripts to do particular tasks, but in practice you will have data that you want to work on, which is typically separated out in a file. Okay, your data can come from the internet, which is just online files being available to us, or it might be on your hard drive. Now, traditionally, we save data directly to files, and files are objects that can be opened. We can write to them, we can read from them, and we can close them. Okay, so open, read, write, close. These are the 4 main operations you can perform on a file. Now, that's a bit oversimplified because, in fact, there's data available which might be too big to fit into a single file. So if you, for example, think about all the websites that Google has in its index, which are billions of websites, they certainly do not fit into a single file, right? They will be stored somehow differently. Or if you think of all the photos that are stored on, let's say, Flickr or Facebook, again, these will not fit into a single file. So in practice, what we deal with is not only files, we are also dealing with so-called databases. Databases allow us to access data in an organized way. Okay. And the technical term for this way of accessing databases is database engines. So database engines are just software programs that are used for accessing data. Now, at the very bottom level of a database, again, we are dealing with files. Right? So files are really everywhere, but not necessarily are we accessing data directly using files. Now, in this course, I'm not going to cover anything about databases, although this is a very important topic, and surely if you start working somewhere after you got your degree in 1 or 2 years, you will have to work with databases. I can almost guarantee this for you, right? So if you're interested in learning about this already now, I put a few references here. There are several modules available for accessing databases and working with them. But here in this course, for now, we will only talk about files. Files are stored on our computer's hard drive or SD card, whatever type of storage you have. And it turns out that this kind of storage is very slow compared to the computer's own memory. Okay? So this particular machine here that is currently serving the projector with the lecture notes has an internal memory, RAM, random access memory of, I think, 8 gigabytes. Okay, it's not very big. Whereas its hard drive has about 300 gigabytes, so much more storage available. But the hard drive is relatively slow compared to the active memory that we're using. Okay? That's described here. And that's why computer scientists have designed a multi-level system of so-called caches. So whenever you work on your computer in the RAM, random access memory, and you retrieve a file from your hard drive, then what happens is this file will go through several layers. So you can think of it as a bottom layer being your slow hard drive. And on top of this, you will have a cache. And on top of this, maybe another cache. And only at the very top of this hierarchy, you have the very fast memory that is being used for processing the file. And why is this being done? This is done because this cache makes sure that we are not directly accessing the slow hard drive, but we have something in between from where we can get our data much quicker. Okay, so that's what is called caching. I put a bit of a description here. You can also find much more on this, let's say on Wikipedia, or talk to me if you're interested in more of these details. But the only thing that you should remember is that you're typically not directly accessing a file on the hard drive, you're actually going through a hierarchy of caches. And this will be important later on when we talk about saving of files. Let me just put a picture of this memory hierarchy. So we have our hard drive, which you can think of as a rotating disk storing zeros and ones. Okay, it's a little bit like a vinyl, but on it are stored zeros and ones, which represent the data that is stored on our hard drive. And now in our computer, we have a hierarchy of memories, which also store zeros and ones. And are referred to as caches. Let's just put two levels here. So we have level 1 cache and level 2 cache. And then on top of it, we have our random access memory, RAM. Which also stores zeros and ones. Okay. Now, if we retrieve a file from our hard drive, then a file will be some portion here. So let's say this fraction here corresponds to your last holiday picture that you took and you stored on your hard drive. And you now want to view it on your computer screen. So what needs to happen is we need to transfer this file from here up to here. Okay. So this file will be read out from the hard drive and it will go to level 1 cache, level 2 cache until it ends up in our memory, and it can then be processed and displayed on the monitor, let's say. I'm oversimplifying here, but essentially this is what is going on. Now, this here is very fast in the sense that I can get information that is stored here very quickly, whereas this is relatively slow. Now, let's say you're doing some modification to this holiday picture. Maybe you increase the brightness and you want to save it back to your hard drive. Well, what happens is that the data that is in your computer's memory is going to be transferred down these levels back to the hard drive. Right? So we can also save information back to the hard drive, which means that we are going in this direction. So this here on the left, we have loading of data, or reading, if you like, whereas here we are saving data. Now, the way information is stored on the computer is typically in one of two ways. There are text files, which can be thought of, again, as a collection of zeros and ones, but together with some encoding. If you have this collection of zeros and ones, you can easily give a meaning to these sequences by just agreeing on a particular way of encoding. So we could agree now that whenever we see a sequence of 0, 1, 0, this corresponds to the letter A. Right? And we could also agree that when I see some other sequence, let's say this one, 1, 1, 0, this corresponds to some other letter, let's call it D. Okay. But this agreement, this mapping between sequences of zeros and ones and characters, that's what is called an encoding. And we can only make sense of text files when we agree on the encoding. That's the first type. The second type are binary files. And these are much simpler in the sense that they only have a sequence of zeros and ones without any encoding attached to it. And of course, it is up to the computer program reading these files to make sense of them. So, we want to deal with both binary files and text files in Python. I put here a list of some of the examples of text files and binary files that you might have encountered. For example, This particular script that I've written called week7.py is clearly a text file, right? I can open it, I can look at it, and I can make sense of it. So somehow with this file is associated an encoding that helps me translating the sequence of zeros and ones into characters. What are examples of binary files? Well, for example, images, movies, or music that you have stored on your computer, or zip files, okay, so packed archived files, or also some of the formatted documents that you process. So for example, with Microsoft Word, these would be binary files. You can actually not just open a Word file and look at it as a text file. You will not see anything sensible in there. You have to use Microsoft Word to open it and read it. Okay, so character encodings. I put here a link. If you're interested in learning more about this, then please follow this. And what is very important is that encodings can differ from operating system to operating system. So not necessarily can you open a text file that is being saved on a Windows machine on a Mac and vice versa. There might be problems, in particular when you're not careful with the encoding. Likewise, binary files, they are much more dependent on the program that produces them. So if you have your own Python script that saves a binary file, you will be able to open that same file on the same machine using the same Python version. But it might not be possible to transfer this binary file to someone else and then just open it on a different machine. You might have some problems there, right? So clearly there are advantages and disadvantages of both formats, text and binary. So let's get started. So how do we actually open a file and write some data to it? It's in fact very easy in Python. So here is an example. Let's say we ask for a user's name. We save this particular string to username, which is our variable for that. And now we want to save it. So when we restart our computer, we still want to remember that username. So let's write it to a file. Okay, in order to write to a file, we first need to open it. And that's done with the open keyword in Python. And the open function takes 3 input arguments, at least. So the first one is the name of the file you're going to write to. I'm going to write to a text file, so my name has file extension .txt, which is a convention, so text files typically have this ending. Then there is another name parameter called mode. I will talk about this a little bit later. And a third one called encoding. So that's exactly this translation between zeros and ones to characters. And the encoding that we're using here, and which is universally accepted, it's very widely used, is UTF-8. Okay? That's the encoding we are going to use. So let's try out what happens here. Okay, I'm going to run this. And I should mention that my file, which is called week7.py, is currently saved on my computer's desktop. So this is desktop, and the file week7.py is on that location. You can see it there. Right? So let's run this. Okay, what's your name? I'm going to type this here. Now when I hit enter, I'm going to open a file called name.txt. I'm going to call the write function on f, which is this variable provided by the open function. And I'm going to write the username, which is the string that we have just entered. And then I will close the file using f.close. Okay, and that's done. So let's look back to our desktop folder. And we find here a file called name.txt. And it is a text file. So I can open it with an editor, for example, Notepad++, which I highly recommend to you if you want to work with text files. And you see, when I open it, the string that we have just saved is in that file. Okay. So in 3 lines of in 3 lines of Python code, we have saved the information that we have produced in our script. So let's go through this step by step and try to understand what we have here. Open clearly opens a file, and the first thing we need to provide is a file name. And there are different ways of doing so. If you just provide the name of a file without anything else, that file will be saved in the location of your Python script. Okay, so I was here on the desktop, my file was located there, therefore name.txt will refer to my desktop. You can also specify subdirectories like so. Okay, so let's say I want to save this in a subfolder called My Files. Then, of course, I can give this information here. And to separate folders from each other, we use a /. So let's try this. Give it another string so we can just distinguish these two files. And everything went as intended. I have my name.txt file now in the subfolder. And when I open it, I have the other string, of course. So that's a different file from the previous one. On Windows machines, you can also, the absolute path to your file is specified like this. It always starts with the drive letter. So on Windows, for example, your hard drive is typically denoted by C. So if you want to save a file directly to your hard drive, to the main folder of your hard drive, it would be C:/ and then the name of your file. Okay, so it would look like this. This will not work on this computer here because I don't have the rights to actually write to the hard drive, but on your own notebook, a Windows notebook, this should just work fine. Now the mode argument here tells Python how to access the file, and we will describe this in some more detail soon. And as I mentioned before, encoding is the translation between characters and 0-1 sequences. Now, among these three parameters, only the first one is mandatory. Clearly, we need to specify a file name, otherwise Python doesn't know what to do. But I would highly recommend that you always have mode and encoding there, just to make sure that we don't get any problems with different encodings. Now, what does the open function return? The open function returns something which is called a file object. So after we have used that function, we will no longer directly access name.txt. We will do all operations on f, or whatever variable name you have chosen there. Right? So after open, we don't actually need to remember how our file was called. We only need to remember what f is. F is a so-called file object. Now, what modes can we choose here? I've chosen WT. What does this actually mean? Well, that's explained here. So W means that we want to open a file for writing into it. Okay, so that's what W stands for. But you can also read a file using the R option. You can use X, which means you're going to open a file, but if a file with the same name already exists, an error will be produced. So let's try this out. If I'm trying to open the name.txt file on my desktop using the X option here, then I will get an error, which is called file exists error, which of course I could now catch with an exception if I wanted to, right? So this will prevent the code from overwriting previously written files because they will be lost otherwise. So that's called exclusive mode, X. And then A can be used to just append stuff to existing files. So if I use this option, and I type some other name here, and I'm writing to that file and then close it. If I now look into my name.txt file, what I'll find is that some other name has now been appended to what was previously in the file. Okay, so A stands for appending. So this allows you to add more and more stuff to your files easily. Okay, that's what the A stands for. And the second letter, which is currently T, just stands for text mode. So we are writing files in text mode, and we can also use B, which means we are going to produce a binary file. Okay. So to summarize, WT as an option for the mode means that we are going to open a file for writing in text mode. If the file already exists, it will be truncated, meaning that all the data that is in that file will be erased. And if the file doesn't exist, it will be created from scratch. Another example, RB, means that we are going to open a binary file for read access. So we want to read from a binary file. It is also possible to open a text file for both reading and writing. In this case, we use the mode option WT+. But in this lecture and probably in the future, it's quite rare to actually do this. So for the moment, you just need to remember W and T for writing in text mode. Now, the second line in our short Python script was just of this format. So we now access the file using the file object. And the file object has a function called write. And the write function takes as input some data. So in our case, it was just a string variable. And that's just the data that is going to be outputted to the file. So that's the write function. And then, of course, there's also a read function. So we can also read information from a file, and it's done like so. If you want to read from a text file line by line, you can have a for loop like this. For line in F, print line. This will just go through all the lines of your text file and print them out to the screen. So let's try this out. So instead of writing, I'm now going to open the file F for read mode. So I need RT here, right? Because I want to read from that file. And now I can have a for loop for line in F, print line. And when I'm done with this, I just close my file, like so. So let's see if this works. Yes, what we have just printed out is indeed the first line from our file, name.txt, right? Just open it again. Here it is. Let's add some more lines. And what you see is that we get one line after the other. So this is an example of an iterator, right? The file object F can actually be iterated over. You can put it inside a for loop. And what you get out of this for loop is one line of the file after another. Now there is another function called readLine, which does the same, but it behaves slightly differently in the sense of a new line character. So what happens when you have a text file with multiple lines, just as the one that I've shown you here, is that there is an invisible character at the end of the line, which essentially stands for new line, so \n, as we have seen before. It's just not displayed by the editor, but it is there. As soon as you hit enter, there is a character there. Now there is another function called readLine, which basically avoids printing the \n whenever you have it there. So there's read and readLine, and they behave slightly differently. And depending on your application, you might choose one over the other. So that's the two operations, write and read. And then finally, we need to close our file. Okay, so whenever we are done with reading all the lines from our file, we will do f.close. So let's examine this code. It opens a text file called test.txt in write mode. Okay, so WT, so it's a text file. Encoding is UTF-8. And all I want to do is I want to write a string to this file, which is defined here. It's called S. and that's what I'm doing. The thing that is missing is f.close, right? I have now omitted that. So let's run this. Okay, the script is finished, and as expected, somewhere I should have my test.txt file. Here it is. So let's have a look. And we see that it is empty. Okay, so omitting f.close might have the effect that actually information is not being written to the file. So let's close it and execute f.close. F is still available, right? And now I'm going back to the file. And there's my string. Okay, so omitting f.close might have the effect that data is lost when you try to save it. And this has to do with the different levels of caches that I explained in the first lecture. Because what happens is when you call f.write and the string, your string that you're going to save to this file might only end up in one of the caches. It will not propagate down to the hard drive. This is only done every once in a while because this is a very slow operation. You want to minimize access to hard drive, right? Therefore, when you save information, it feels like you have saved to the hard drive, but actually you haven't. It's stored in a cache somewhere in between your RAM and the hard drive. And only f.close makes sure that the cache is emptied and really written to the hard drive level. Okay. So it's important to have f.close at the end of your write operations. Now, of course, there is a more efficient way of doing it, writing and making sure that you don't forget f.close. And this is done with the with keyword. So there is a construct in Python, which is the with s construct. And what it does is it takes the file object that is being returned by the open function, and we put it inside this with open sf construction here. So it is equivalent to what we have done before in the sense that after this f will be a file object that you can work with. In particular, you can write to it. But the difference is that here you don't need f.close. This f.close will be called implicitly when you leave this with block here. So as soon as you're done in this with block, you exit it, close will be called automatically. So let's try this. I will get rid of all my text files on a desktop. Okay, we just have f.write username, and here it is. And it has successfully saved the name to the text file without using f.close. So I would recommend using this particular way of writing to files because it's not so error prone. f.close will even be called when this block here is left with an exception or a return statement. Okay, so in either case, Python will take care of saving the data to the hard drive as you intended to do in the first place. That even works across functions. So here again, we have with open sf, but now I'm not calling f.write in the main program. I call f.write in the function, which we have here, right? So this saves the formatted string to our file. Even here, when this function is finished and you return, f.close will be called implicitly. All right, so we now know how to open and read from text files. So let's look at a slightly more interesting example. What I'm going to work with now is a file that is available on the course website. You can download it. It's a file that collects the average house prices throughout the UK from 1995 until 2016, I believe, with some seasonal adjustments. Okay. Now, this data is organized one record per line, so we will have multiple lines in this file, and the format is very specific. I guess I just show you the original file as it is. So here it is. Now, this is a so-called CSV file. You can see this at the extension, which is .csv. If you just double-click on it on Windows, it will open Excel to look at this file. I recommend not doing this. I would recommend right-clicking and then opening it with a text editor, for example, Notepad++. This is because Excel might actually mess up this file when you save it, okay, and then it's no longer usable. So here is all this data that I've downloaded. And the format is that in the first line of our text file, we have a description of each of the columns. The first column will correspond to a date. The second column will correspond to a region in the UK. And the third column will be the average house price. Okay. And now every single line here is exactly of that format. We have some timestamps. So for example, this is January 1995. This is the region called Barking and Dagenham, something like that, comma, and then we have the average house price. Because it's an average, it has many decimal places, as you can see there. And there it goes. So here are all the entries. And I believe this data goes until March 2016. There might be a more up-to-date file available now, but that's the 2016 version. So what can we do with this? Well, actually, this is very, very useful information, right? We can now start analyzing this data, maybe find the region in the UK where house prices are cheapest compared to neighboring regions, or maybe find regions in the UK where house prices have gone down instead of going up over the last 5 years, right? Having this kind of data available and Python as a tool to analyze it is extremely valuable to us. So let's start easy. I want to write 2 different programs. The first one will do a simple task. It will load 2 positive integers, f and t, and it will then copy the first line of the file that I've just shown you, because this was the description of the information, and then all the lines with indices f up to t into a new file. Okay. That's the first part. And then the other program that we are going to write now is one that takes as input a name of a region and then prints the average house price in that region for all the data that is available. So since 1995, what was the average house price in Manchester, say? If you're interested where this data comes from, it's from this website linked here. It's the Land Registry. It's freely available for download. So here's the first task: copy a part of this file to another file. In order to do so, we need to know the name of the output file. That's what I'm getting here. Let's call it oname for output name. And then we want to copy from line number f to line number t. So let's get the corresponding integers here. Now, if I want to copy from one file to another, I need to open both of them. Right? The first one will be for reading, because that's where I get the data from, and the other one will be for writing. And that's done with this with command here. So I open the source file, which is called averageprices.sa.csv, for read mode, RT. It's stored as a UTF-8 format. That's the encoding. And the name I'm going to give to this file is ifile. It's the input file. But I need another file, actually, right? I need one for reading and I need one for writing. And you can use this with syntax with as many files as you like. You just separate them by comma. So I put a comma here, and the backslash means that my command will extend to the next line. In Python, you cannot just hit enter and then continue the code on the next line. You need to tell the interpreter the stuff that follows now should actually be here, but there wasn't enough space putting it there. So I'm going to open a file with name oname. That's the one that I've asked from the user. I want to open this file for write mode, so WT, and the encoding will also be UTF-8. And the file object name is called ofile. So we have ifile, input file, and ofile for the output. Now, let's go through this line by line. The first thing I want to do is I want to grab the leading line in the input file which is this one here, right? Line number 1 is kind of special because it gives some information about the data. I want to read this one line and copy it immediately to the other. And that's done here. So from the input file, read line will read the first line. This gives me a string of the information in the first line, and I'm going to write it to the output file. ofile.write, the string that I got from the input file. Okay, so we are done with the first line. Now I want to only copy information from line with index f up to t, which means I now need to skip all the files that have an index, all the lines that have an index less than f. Right? So what I'm doing here is I'm just writing here a for loop for range f minus 1, and I'm going to read line from ifile repeatedly, but I'm not actually using it. I'm just reading it and throwing it away. Now there can be a problem, right? Let's say I want to copy the information from line 20 to line 30, but my input file has only 15 lines. Then obviously there's nothing to copy, so I will stop. Now this occurs when readLine returns an empty string like this. When readLine returns an empty string, you are sure that the file is, we are at the end of the file. There's nothing more to read, right? So if we happen to encounter an empty string, we will just break the for loop because we are done. Otherwise, we keep on reading lines. And now I need to copy t minus f plus 1 lines from the source file to the output file. So let's have a for loop for k in range t minus f plus 1. And let's read the corresponding line from the input file and call it line. That's just the variable name. When, again, if this is an empty string, we have reached the end of our file, so we can break the loop. Otherwise, we have to write the line variable to the output file. And that's it. So this code should hopefully copy the first line over from the input file to the output file, and then all the lines with indices f up to t. So let's see if it actually works. Now again, it's important. I'm going to open the file average prices sa.csv. My file, that is my Python script, is called week7.py, and it's stored on my desktop. Therefore, this file that I'm going to use needs to be in the same folder. Otherwise, I will get a file not found error, right? So let's run this. Let's call the output file name output.csv. And let's copy from line 10 to line 25, say. That's done. And now we should somewhere have our output CSV. Here it is. And when I open it, indeed we find that we have 17 lines, with the first one being the header of the input file that we have just copied without modification. Okay, so that's how easy it is to extract a certain portion of a text file and copy it to another. Now, just to remind you, we have checked whether we have reached the end of the file by verifying that the string is empty. Now, clearly, you can have text files which have empty lines in them, right? So, for example, you could have a text file of this format. Now, when you use readLine on this text file, then at line number 7, you will not be given back an empty string. You will be given back a string that has the line break in it, this invisible character \n, right? So there's a difference between an empty string and the string that contains a line break. So the stopping condition that we have in our code here, this will not be triggered when you have empty lines. It will only be triggered when you reach the end of the file. Okay, let's look at another program. Let's get the average house price over the years 95 to 2016 in a particular region. How are we going to do this? Well, we need to first decide what region to look at, and the variable is called name. Okay, so I'm going to just ask for the region's name. And also, because I don't want to deal with capitalization, I don't want to make a distinction between capital Manchester and lowercase Manchester, I will just transform this input the user provides to lowercase characters, like so. Right? So from now on, we will only deal with lowercase letters. Now, how do I get the average house price in a region? Well, I need to go through this text file line by line, right? And let's say I want to compute the average house price of Manchester. I need to find all the lines where the region corresponds to Manchester. So here's an entry, line 99, that would be the first one. This is in January 1995. This is the average house price back then. But I'm not done yet, right? Now I need to find the next one where the region is Manchester. And now it's 46,000 roughly. And I want to compute the average of all of these. So we need to go line by line again. And that's pretty much what this code here does. I'm going to open the file using read mode. The file object is called f. Now I will skip the first line because this first line does not contain any prices, just a description. So I have a single f.read line here. Now I need to compute the sum of all the prices, and I need to count how many prices I've encountered for computing an average. So let's initialize these two variables at 0. And then for each line in my file, I'm gonna now read out each of these lines, and I'm going to split at the comma, right? Because the data that I have here is comma separated. So if I read this in as a string and I split it at the comma, I will get an array with 3 entries, each of which corresponding to the particular columns, right? So if I split using a comma, I should be given something which contains 3 entries. And here I use an assignment to a tuple with which can take 3 values. I'm not interested in the date itself, so I use a throwaway variable. The information in the second position is the name of the category, which is the region's name. And the one in the third position is the price at this particular date. Now, what do we need to do? If this category name is the same as the one we want, let's say Manchester. In other words, when the category name converted to lowercase characters is our lowercase character category name, then we want to increase the sum of the prices by price, which is what we got here, right? The third argument after splitting. And we want to increase the row counter by 1. Now, notice that this is a float conversion here because when we read from a file, clearly we get strings back, right? So if I want to add these values using the price sum variable, I need to first convert it to a floating point number. Otherwise, the adding operation is not defined in the way we want it to be defined. Now, in any of these here, an exception can occur. So I'm trying to make the code robust by putting all of this into a try except block. Whenever we encounter a line where something goes wrong here, we will just pass. We will just go on to the next line. Now, what could, for example, go wrong? Well, look at this line here. So I'm going to split each of the lines using comma. I'm expecting a tuple with 3 elements, right? If someone had modified this file so that one entry has some other stuff like so, if you apply split to it, you will now get 4 entries, and the assignment to a 3-entry tuple will of course fail. So that would be an invalid line in our file, and we want to not just crash the code, we want to just ignore it and go to the next one. I'm not going to save this because this file is actually fine. It has exactly 3 entries per line, and they are comma separated. Well, and when we are done with this, we can compute the average house price, right? So price sum divided by row count should give us the average. Category name. So let's start with Manchester. What was the average house price over the years from 95 to 2016? That's 78,000 pounds, roughly. And there were 255 records. So as I went through this file, I also counted how many times a record occurred. We can also ask for the average house price in Greater Manchester. What do you expect this to be, greater or smaller? Manchester is the city center, I think, so I think the prices there should be higher compared to the average of the whole region, right? So I would expect this to be smaller, but it's not. Okay, so we are surprised. Maybe it includes all the regions where the footballers live, right? Which count not towards the city center. We could now, of course, go through this text file and analyze which are the regions that actually increase the house price so much. Let's look at maybe London. Will it be higher or lower than Manchester? Higher, right? Okay, significantly higher. 270,000 pounds compared to 78,000. Now you can imagine that it can become much more complicated. Let's say you have a comma-separated files where the entries themselves have commas in them, right? These might not be cities, this might be some other information, and you might want to have commas here. It becomes immediately much more difficult to actually read this file manually and do the splitting using the split operation by commas. And for this reason, and because comma-separated files are so important, there is a module called CSV, which does most of the work for us. Okay, so this makes it much easier to read comma-separated files. So this is exactly the same program, computing the average house prices over a couple of years, but now using the CSV module. In order to use this module, I need to import it, so import CSV. And the only changes that we have here are that instead of having read line, one after the other, we define an object called prices reader. You can call it whatever you like, using the reader function of the CSV module. So csv.reader is a function that you can call, which takes as input the file object f, and we need to also tell it what is the delimiter in our CSV file. Well, in our case, it was a comma, right? The entries were all separated by comma, but there are other files which have different separators. So you can easily handle these. And otherwise, the code looks pretty much the same, except that we have here a for loop for row in prices reader. So we are now not iterating over f, line by line. We are iterating over prices reader, which we have defined here, and we get one row at a time. These are the main differences. Okay. And then again, I'm going to get the three fields for each line. I get them directly from row. I do not need to use split here because this prices reader does the splitting for us. So I immediately get all these three values in one go from the row object. Otherwise, the code is the same. What is also nice is we don't need to read the first line separately. That's actually done automatically by the CSV reader object, right? The first line is skipped. If you don't want to skip the first line, you need to tell it explicitly to include it in the iterator. So that will do exactly the same thing, but in a slightly more convenient manner. The CSV module also allows to open Excel files that have been exported as CSV. So when you, for example, work in Excel, many of financial data, for example, are handled in Excel. There's always an option to save as a CSV file, and once you've done this, you can very quickly open this CSV file using the CSV module, like so. Okay, so it's a very useful module, I would say, and I would recommend using it whenever you can. There are other text formats, just to have them mentioned here. There are so-called XML and JSON formats, and for both of them, again, there are modules that allow you to open and read from them very easily, and corresponding links are given here. We are not going to use them in the lectures, but in the future you might want to go back here. Good, that was all I wanted to say about reading and writing text files. Now a little bit about binary files. Binary files are sometimes more efficient and also more flexible in the sense that you can store arbitrary data types in binary files. And the module we are going to use for this is called Pickle. It's the Pickle module. So in order to work with binary files, we are going to import the Pickle module, just like so. And as before, we are going to open a file, but now not with the text mode, but with binary mode. So I've changed the T to a B here. And also as a file extension, I'm using .dat, which is a common way of denoting binary files. So this is going to be my binary file, .dat, and it's opened with the with open s construct, just as we did before. Now, in order to save stuff to a binary file, we have the function pickle.dump. Okay, so what it does is it takes a variable, in this case 17, that's just the value to be written to our file, comma, and then the file object identifier f. So this is going to dump the value 17 to the file f. And this here, the second line, is going to dump the value of 17.19, which is a floating point number, to f as well. So let's try this out and then have a look at the binary file that we have created. Okay, so that's done. Let's look on the desktop. There should be now a file called binary.dat somewhere. Here it is. And I'm going to open it using Notepad. And what you see is this here, right? So completely cryptic. Well, the reason is this is not a text file. This file is not meant to be opened in a text editor. So there's no way to make any sense of it. But the data that we see here is really a representation of an integer 17 and a floating point number, right? Just not, we cannot parse it using an editor. Right, I've saved my data to the binary.dat file. How do I open it? Well, as we expect, we have to open the binary file. Now in read mode, the file handle is called f, and now I'm going to call pickle.load. So this will load information from the file, and the file identifier is given as an argument, and what I get back will be assigned to the variable x. I've written two values, right? First the integer and then the floating point number. So I can call pickle.load twice to also get the second value here. And you see what we get are indeed the values 17 and 17.19 in the variables x and y. And what is very nice about binary formats, and in particular the Pickle module, is that the type of the data has been preserved. So when we stored the 17, it was actually stored as an integer, and when we stored the 17.19, it was stored as a floating point number. And after loading, these variables are again floating point numbers. We don't need to do any conversions back to floating point format as we had to do with the house prices previously, right? So that's an advantage of the binary format. Now, the stuff that you can save can be much more complicated. You can store a whole dictionary like this, right? You can store arbitrary data types using the Pickle object, and Pickle will take care automatically about the conversion of the different data types for you. Now, when we read binary files, what goes on internally is that there is a counter for the position that you're currently at. So you can imagine this binary file has an integer 17, which will occupy some space in this file, maybe from the beginning till some position. And then after this value of 17, we have the floating point number occupying the rest, right? And that's obvious because we can call pickle load twice, and it will get the information at the first position and then the information at the second. So somewhere internally, there is a pointer to the current data that we are retrieving. Now, this position can actually be queried, you can get information about this position using the tell function. Okay, so tell gives you back an integer value corresponding to where inside this binary file are you currently reading. So if we open our binary file for reading like so, we can ask for the current position. And if we just open that file, we are at the beginning, so the position will be 0. I'm now going to load x, which was the integer value 17, using pickle.load. After I read this information, I'm going to ask again, where is the pointer now? And it turns out it is 5. Okay, so after reading the integer value into our variable x, we have moved 5 positions forward in our file. And then I'm going to read the last variable y, which was a floating point number, and I will ask again, after reading this variable, where am I located now? After reading this floating point number, I'm at position 17. So somehow the floating point number has occupied 5 spaces in memory in this file. The integer has occupied 5 spaces, whereas the floating point number has occupied 12 spaces. Right? And that kind of makes sense that the floating point number needs more space to be stored in this binary file than the integer. Okay? And we can kind of see this from these pointers. So ftell returns the current position in the file in terms of bytes. Okay, and we can also use this pointer to move back and forth between different entries in our binary file using the seek command. So what seek does is it takes the file object f, and then you give it an integer value of the position that you want to go to when reading information from the file. So if I remember the position of the integer value, of the floating point value from before, the position was called position between x and y. I can seek directly to this position, and I can call pickle.load, load the information at this position, and what I get is exactly this floating point number 17.19. It is easy to move to the beginning and to the end of a file. So f.seek 0 will always correspond to the beginning of a file, whereas if you want to go to the end of the file, you need to do something a bit more complicated. You would need to import the input-output module IO, as shown here, and then you can call this construct here. So this will seek to the end of a file relative to the beginning of the file. So in this case, you would need to provide 2 inputs, 0 still corresponding to the beginning, and IO seek underscore end will essentially correspond to the length of that file. So when you seek to the end of that file, you do it always relatively to the beginning of that file. That's why we need to call it with 2 arguments here. As a summary, this pickle module is very powerful. If you, for example, have to save dictionaries and you don't really care about the format of it being saved, so if you don't want to look at the file and see that it's a CSV file, I would encourage you to use Pickle.